All right, everyone, welcome to Chapter 10. This is Nick Jacobs, your intermediate algebra instructor here at Yavapai College. Today, we're going to start Chapter 10 and go through Section 10.1 on radical expressions and functions. So a few objectives today. We're going to introduce radical expressions. We're going to recognize square root functions and their properties, and also recognize cube root functions and their properties. So just to recall, a square root is basically a number, let's say b. It's a square root of a if b squared equals a. These are some examples of square roots. Okay, and we could go the opposite way here, where 2 squared would be 4, 3 squared would be 9, 4 squared would be 16, etc. That's this property up here. So it is good to know some of these, or all of these, at least up to 20, so that you can recognize those when you come across that in a problem. So let's just go through some notation and some definitions. So basically, every positive number has 2 square roots, one positive and one negative. Generally, we're just going to be focusing on the positive number, but we will come across some situations where we're just going to say the answer is actually in the absolute value form. But generally, I will let you know when I'm requesting that. But just kind of recall that a positive square root is called the principal square root. And that's what we'll mainly be focusing on. The symbol for a square root is actually called the radical sign. And it's assumed, if it's like this, it's assumed really that it's like this, where we have a 2 there for the square root, right? If we have a cube root, right, this will be a 3. Fourth root, this will be a 4, etc. But the expression under the radical sign is called the radicand. So anything that's under the radical is the radicand. So something like this is going to be the radicand. You don't really have to know that, but I might refer to it. So it's good to know that definition. And then an expression containing a radical sign is called a radical expression. Okay, so here's some examples of radical expressions. You can also have numbers outside of the radical as well. So, all right, let's evaluate some pretty simple square roots. Okay, so the square root of 36. So again, you're saying what two numbers multiply that are the same number to give you 36, and we know that that is 6 because 6 squared is equal to 36. 0.64, the square root of that would actually be 0.8. And you should be practicing how to type these in on your calculator if you're not sure. But again, that's because 0.8 squared, or again, 0.8 times 0.8 is equal to 0.64. In a situation like this, where we have a rational expression inside of a radical, what we can actually do is something called the quotient rule for radicals. So we can actually break this up into 2 different radical expressions with a division sign, right? So we can put this division sign, we can break up this into a numerator and a denominator, and then take each of those square roots by themselves. So the square root of 16 is 4, and the square root of 25 is 5. If you're hearing noise in the background, I apologize. But anyway, let's approximate the next one. So the square root of 38, that's not a whole number. Okay, so it's not really a nice number. So we have to round it. Let's round it to the nearest thousandth. Okay, so if you typed it in on your calculator, you would get something like this. Notice if you do a radical, if you're using a graphing calculator, you'll want to put that number in parentheses. So when you type it, it'll have kind of this this first part, and then whatever you want actually under the radical is going to go in parentheses like this. And then it's always best practice to close it off like this. You don't need to in this case, but just in case you had other numbers over here, you would need to close this off to just tell your calculator that, yeah, I want the square root of 38 under the radical. And then if it did have anything else, like +5, for example, you would have the +5 on the outside after you close that off. So let me get back to this. Let's round to the nearest thousandth. And again, this is the tens place where the 1 is. The 6 here is the hundredths, and then the 4 is the thousandths. And remember, we always look 1 to the right, and 4 and below, we're just going to keep this the same. So your answer is 6.164. All right. Now let's get on to cube roots. So again, the number b is a cube root of a if b cubed equals a. And here I had kind of both ways, and I went up to just 7 in this case. It's kind of the ones that I know. And again, that might be good for you to know too. But if I have 2 cubed, that's going to be 8. And again, kind of going the other way, the cube root of 8 is 2. Okay. Or 5 cubed is 125. The cube root of 125 is 5. So 5 times 5 times 5 is 125. So some examples there. But let's evaluate some of these. So evaluate the cube root. What's the cube root of 64? So again, the cube root of 64 is just going to be 4. And again, that's because 4 times 4 times 4 is equal to 64. Or you could say 4 cubed is 64. That's the same thing. So the next one, we have the cube root of negative, in this case, 125. And in this case, it is okay to have negative numbers here, okay? So we can do -5 times -5 times -5. That, this is times a -5. That gives us -125. So the cube root of -125 is in fact -5. But just to note here, if I had, let's say, the square root of -25, that is not a real number. So this is not a real number. So it's not defined, really. Okay, you could say it's undefined. Okay, or it's not a real number. Okay, a couple different ways to say that. I haven't double checked your homework. I don't know what way they're gonna make you do that if it is. But again, the reason this one's not defined is because, you know, you can't take, well, -5 times -5 does not equal -25, and it has to be the same number. Okay, so obviously 5 times 5 is +25, kind of the same case here. And I'll talk a little bit more about this. But basically, if you have a negative number and there is an even root, okay, you can't have that. It's always going to be undefined. Again, I'll talk about that more in just a moment here. But in this example down here, let's move on. This is the cube root of 1/8. And just like the other one where we had the square root of 16 over 25, I can in fact use that quotient rule and break this up into the cube root of 1 divided by the cube root of 8. And again, the cube root of 1 is just 1. 1 times 1 times 1 is 1. And then a cube root of 8 is 2. All right, 2 times 2 times 2. So cube root of 1/8 is equal to 1/2. All right, let's get into some rules of exponents, okay? Or not exponents, of radicals. So this is going to be basically rule number 1. Actually, let's see here. This, I don't know. Let me look ahead. I don't know if I want to actually write this down as a rule. I'm actually not going to write this as a rule yet. I think I wanted to focus more on rules of radicals and exponents in 10.2. So I'm actually gonna save this, but this is just some notation, okay, that we've done right now. And this is more on that rule if we have a negative number inside a root here. So basically, the equation, basically the, I can't talk right now. I'm trying to figure out what I'm going to say. If I have the root n of a, that equals b, okay, because b to the n is equal to a. So you can kind of switch back and forth between these. That's the whole point here. So I could take this expression here, or this equation, okay, I could take this guy and I could put it into this form if I wanted to. These are interchangeable. That's what I mean. Okay. If n is odd, we're finding an odd root. Okay. N is even, we're finding an even root. That's just some terminology. But if a is equal to, or sorry, if a is greater than 0, then root n of a is a positive number. But if a is less than 0, again, if it's negative, okay, we can get an answer. We can get a real number if a is negative, okay, and the power is odd. But if n is even, then this is not a real number, as we just saw with square root of negative 25. And I said at the beginning that we assume that if it's a square root like that, that power is a, or that root is an even number. Okay, same thing like with if I tried to take the fourth root of negative 64, that would also be undefined or not real. Okay, not a real number. Okay, but I can take the cube root of negative 64. Okay, that's going to be negative 4. Okay, because I have an odd root, right, with a negative number. I can do that. That's this rule. Okay. All right, find each root if possible. So, kind of a hint there that one or more of these might not be possible. Well, this one I don't have to worry about, right? Let's see. Yeah, I wanted to do that. Let me just click ahead here. So the fourth root of 256, I can in fact do that. They're both positive, so this is positive, so I don't have to worry about this being an even root. But this is going to be 4. And why is that? Well, that's because 4 times 4 times 4 times 4, or 4 raised to the 4th, is equal to 256. Okay, so this is 4. This one is actually going to be negative 3. And you can use your calculator for this. So if you don't know how to use your calculator to type this in, please let me know. I can kind of work with you on that, because every calculator is different. I don't want to say, hey, I'm going to use the TI-83 plus graphing calculator for this. And then if you have a different calculator, then you won't know how to do it. Okay, so I'm not going to show people, 3 different calculators on a lecture. Okay, but if you have questions about how to type any of this in, please let me know. But anyway, this is going to be negative 3. And why is that? Well, again, because negative 3 times negative 3 5 times is negative 243. Or you could say, again, that negative 3 to the 5th is equal to negative 243. You kind of be careful with this, because if you have negative 3 to the 5th like this, okay, it is, and it is in this case negative 243, but you just have to be careful, because if I have something like negative 5 squared versus negative 5 squared, this one is going to be negative 25, and this one is 25. And that's because here you do order of operations. You take the 5 squared first, which is 25, and then you kind of times it by this negative 1. Okay, this is kind of like a negative 1. This really means like negative 1 times 5 squared. But in this case, this one is negative 5 times negative 5, okay, which is positive 25. So just kind of be careful with that. And then the one down here, well, we have an even root with a negative radical expression here. And again, we can't have that. Okay, so this is undefined. This is not a real number. Okay, and that's again because we have an even root, okay, of a negative radicand. Oops, radicand is not real. Okay. All right, let's move on. Here is a rule for when we do the absolute value. Okay, so for every real number x, okay, just imagine this is a real number, x squared is going to be the absolute value of x. Okay, so, and I will give you hints on this. Okay, I'm going to say, all right, this is one where you have to worry about absolute values. Okay, because technically, right, if I have the square root of 25, right, that could be 5 or it could be -5, right? But generally, I don't have to worry about that. Okay, you know, I could say that that's the absolute value of, you know, whatever your answer is. Okay, but I'm not going to worry about that. So just pay attention to this rule. Let me do a few examples. I'll show you kind of what that is here. So here is kind of that case of the 25, but I wrote it in -5 squared form, okay, with the parentheses. Okay, so let me click ahead here. So if I have this guy, okay, and again, our rule is the square root of x squared is equal to the absolute value of x. Okay, what is x in this case? Well, it's -5. So I'm going to have the absolute value of -5, right, for my answer, which is equal to +5, right? So that is the answer for that one. Same case here. So I would have the absolute value of this expression, x + 3. And since nothing is negative here, I don't have to worry about this. This actually is the answer. And then in this case, I would have to do some factoring like we did in our first chapter, chapter 6. So I can factor this guy. This would actually factor into w minus 3 times w minus 3, which I'll extend that radical a little bit, which we know is w minus 3 squared. And now I take my absolute value rule, which says that this is the absolute value of w minus 3. Okay, so that's the answer there. And again, I'm going to give you this, you know, this kind of hint here. Write each expression in terms of an absolute value. All right, if possible, evaluate these guys. Okay, so evaluate for f of 1 and f of -2 for each of these two functions. Okay, if possible, again, kind of giving you a hint, maybe one of them, or you know, some of them are not possible. So let's do that here. Let's find in this function f of x equals square root of 5x plus 1. Let's find what f of 1 is here. So again, all I do is I take the 1 and I plug it in for x, and then I simplify. So 5 times 1 is 5. 5 plus 1 is 6. So this is going to be square root of 6. And then let's do the other one, f of -2. So I'd have 5 times -2 plus 1. And 5 times -2 is -10. -10 plus 1 is -9. But what happens there? Well, we have a negative number or a negative radicand inside of an even root. Okay, so this is undefined. This is not a real number. And we will get into some imaginary numbers here at some point. But for now, just know that this is not real. So let's do the next one. We have f of 1 for this guy would be 1 squared. I always use a parentheses when I'm plugging it in to anything that's squared or something, or even over here when I substitute it, I use parentheses. That's just best practice. Okay. You're not gonna, your odds of messing up are gonna be a lot less likely if you use parentheses. But this is gonna be 1 squared is 1 plus 4 is 5. So that one was pretty easy. And then f of -2, let's plug that in again. You might want to use the parentheses. And the -2 squared is 4, and 4 plus 4 is the square root of 8. And we will get into, we can break this down, okay? This actually breaks down into 2 square root of 2, but for now, we don't have to worry about this. We just have to know that it's the square root of 8. Oops, okay. Let's do a word problem example. So calculate the hang time for a ball that is kicked 75 feet into the air. Does the hang time double when a ball is kicked twice as high? Use this formula. So this means a time of x of x feet. That's basically what this means. So this is x represents, x is going to be equal to feet in the air. Okay, and this is the time. So it's time of x, or time of feet in the air. So how long did it hang in the air, basically? Okay, or hang time. Okay, so the hang time is, so if it's 75 feet, we're just going to plug in 75 for x. And then simplify this down. Actually, let me save some room here. I'll just keep going to the side. This is going to be, and you again, type this into your calculator, okay? Actually, let me do that here. So this is going to be, let's see, 1/2 and square root of 75 gives me 4.33, and then 0.127, blah, blah, blah. Let's just round that to the nearest tenth. So this is going to be about 4.3 seconds. So what if we double it? Okay, so what if we double? What is the hang time now? So double the height here that the ball is kicked into the air. 75 times 2 is 150. So let's find the hang time of that. And that's going to be about 6.1. So let's answer the question now. Does the hang time double when the ball is kicked twice as high? No, because if I doubled 4.3, 4.3 times 2 is 8.6. 6.1 is not double the time. So no, right? The hang time is less than double. You can try this formula on your own, right? Get a kickball, okay? Go out to an open area or something. Kick it, see if this formula works. I don't know where they got this formula, but maybe it's right. I have no idea. I've never tested it myself. So you'd need a pretty big tape measure to know how high something is, or maybe if you're in an open area by a building and you know how tall the building is, kick it as high as the building or something, if you can. Okay, or have somebody who can do that. Do a little experiment. Okay. All right, we're almost done with this section. A couple more things that I want to talk about. First is domain. So we're going to find the domain of these radical expressions, and then we're going to write the answer in interval notation. So the point of this here is, again, domain is x. What can x be? Well, in this case, basically, I have to have a positive number, or not necessarily positive, but some number that's greater than or equal to 0 inside of the radical, right? Because if this is an even root, this number has to be positive. That's what we talked about. So when I'm trying to find the domain here, I need to set the radical expression inside the radical, I need to set that greater than or equal to 0. And that's going to allow me to find the domain. Okay, so now all you have to do now is solve it. So if I'm solving this, I'm going to subtract the 3 over here and then divide by -4. Now, what happens when you divide by a negative? Just kind of review from our last chapter, we're going to have to switch the sign, right? So this switches. -3 divided by -4 is positive, because we have two negatives. Two negatives make a positive 3/4. And again, the sign flips. Don't forget to do that. Okay. Sign flips. If you're just reading through the notes, remember this. I'll just say recall, right? The sign flips. So they want it in interval notation, which again means I have to use parentheses or brackets. Well, this one, again, is everything less than 3/4. So it would go all the way down to -infinity to 3/4, and it's less than or equal to, so I need a bracket. So this is your interval notation. Now this guy, if I do the same thing to start, right, we set the radical expression greater than or equal to 0. Let's subtract the 4. Well, any x number that I put in here is always going to be greater than or equal to -4, because any x, in this case, is going to be positive, right? Or sorry, so what I mean, so any number that you choose for x is going to be greater than or equal to -4. It has to be, right? If I have -1, right, and I square that, that's +1. If I have -5 squared, that's +25. Okay, and then obviously positive numbers. So in this case, since any x that we have is going to make this greater than or equal to -4, basically in kind of very non-mathematical terms, any x will work. Okay, so what does that mean? That means the function is defined for all real numbers. So f of x, in this case, is defined for all real numbers. Okay, so that means that in interval notation, I have -infinity to infinity. All right, last one, I'm going to do a homework question. Now you are very welcome to use Desmos, right, for this. So you have to graph this. Graph the equation y is equal to the cube root of x plus 3. Compare the graph to y is equal to cube root of x. Well, you could make an XY table if you don't want to use Desmos, okay, or your graphing calculator if you're using those. But I'm just going to do this one by hand. And because this is a cube root, I'm going to want to choose numbers that are perfect cubes. So for x, I might choose something like -8, -1, 0, 1, and 8. Okay, that's going to give me a good bearing here on this guy. So I'm graphing this here, and you can compare it to this graph. Okay, so this is going to be basically the graph of the cube root of x plus 3. And then you can make another table over here if you want of just the cube root of x. So you could even choose the same values if you want. Okay, so let's plug it in here. -8, or the cube root of -8 is -2 plus 3 is 1. Cube root of -1 is -1 plus 3 is 2. I'm going too fast. Slow yourself down and try these, or type them into your calculator. So this is going to be 4, and then this is going to be 5. And here, this is going to be a -2. This is going to be -1, 0, 1, and 2. And maybe I want to, well, let's just do this guy first. So -8, -1. I believe this graph goes to -7. So -8, 1 is here. You guys know, if you watch my other lectures, how much problems I have just filling in a circle dot. because of my pen that I'm using. But this is -1, 2, 0, 3, 1, 4, and 8, 5. It's going to be right about there. So this one kind of looks something like this. I actually did pretty good drawing that. I'm impressed with my skills there. And then this one, let's do this in red. This one's going to look like -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So what happened here? We kind of learned a little bit about this in chapter 8, but this +3 just moves this every y point here up 3. Okay, that's basically what it does. But this is going to eventually, the blue one is going to eventually drop below the x-axis, just so you know. Because if I had like -64, right, if I plug that in for x, the cube root of -64 is -4 plus 3 is -1. So it is going to drop below eventually, like -64 somewhere over here, and then -4 down there. So again, feel free to use Desmos if you want, but also just know this is kind of a review from chapter 8 on how to compare those graphs. So that is section 10.1. So if you have questions, again, please reach out, especially if you have calculator questions. And in 10.2, we will be going over the some rules of exponents and when we have radicals and all that stuff. So we'll see you then. Have a good one. Thanks for watching.